Hello everyone. In this session, you will learn how to solve the non-homogeneous system of first-order linear differential equations. We will use the method of undetermined coefficient to solve the problems. So in general, we will divide the step of solving the non-homogeneous system of first-order linear differential equation into four main parts. These are the steps in solving the non-homogeneous system of first-order LDE. The format is y prime equal to ay plus g. So part 1 is to find the general solution yc for the homogeneous system. Then second step is to find the particular integral yp for the homogeneous system by using the method of undetermined coefficient. Then the third step is to obtain the general solution for the system of first-order linear differential equation by y equal to yc plus yp. Then step number 4 is to find the particular solution by considering initial condition. This one is if the question given only. As you know, the homogeneous linear differential equation is y prime equal to ay. If non-homogeneous, so your linear differential equation will be the y prime equal to ay plus g. So this g component can be polynomial, exponential, or sinusoidal function. So sinusoidal function can be sine or the cos only, or sum of the product, okay, sum or product of this. This is the step to find the yp, particular integral. So the first step is to assume the yp based on g. This is the table of assumption for the g. So in case 1, polynomial, if the g component is a polynomial, either this one, or this one, so you will get the yp is either this one, or this one, based on the g component. And second case is the exponent. If you have exponent case like this, so your yp will be like this. So if yp same as yc, then you got to multiply with x. So u1 x plus v1. Okay, so this is how you assume the yp. And similar to the case 3 trigonometry, you have the sine or the cos. Okay, so after you assume the yp, then you can find the yp prime and then compare the yp prime with the yp. So yp prime is from the step 2 and y prime is from the system of equation given. So is ay plus g. Then by equating the coefficients. Now let's look at the example. Find the general solution and a particular solution of the following non-homogeneous system of first-order LDE. Here you have the y1 prime equal to negative 3y1 plus y2 minus 6 exponent negative 2x. And then y2 prime equal to y1 minus 3y2 plus 2 exponent negative 2x. Then this is the initial condition value. So by using the method of undetermined coefficient, so you need to find the general solution and particular solution. Okay, so this is the question. So first of all, you need to find the general solution, that is the yc, for the homogeneous part first. So find the general solution. So in order to find the general solution, you need the first step is the metric form of the y prime equal to ay plus g. So a from this question, that is the minus 3, 1, and then 1 and negative 3, y plus g. G is minus 6 exponent negative 2x and 2 exponent negative 2x. Okay, so then Second is to find the eigenvalue and the eigenvector. So now we have minus 3 minus lambda. So only this minus 3, this one will minus lambda. So minus 3 minus lambda 1, 1 minus 3 minus lambda 0. So minus 3 minus lambda multiply with minus 3 minus lambda minus with 1 and 1. Okay. So now this one will multiply, negative 3 will multiply this one. So 3 times 3 you get 9 plus 3 lambda plus 3 lambda plus lambda square minus 1 equals 0. So you have lambda square plus 6 lambda plus 8 equals 0. So when you factorize it, you will get lambda plus 4 and lambda plus 2. So therefore, lambda equal to minus 4 and lambda equal to minus 2. So now, for lambda equal to minus 4, so you substitute the lambda into the matrix here. Okay? So you have minus 3 plus 4. Because minus 3 minus lambda, so minus 3 plus 4. 1, 1 minus 3 plus 4. X, y equal to 0 and 0. So negative 3 plus 4, so you get 1. 1 times with x, you get x. And then plus with 1 times y, you get y equal to 0. Same to here, 1 times with x, you get x, plus 1 times with y, you get y. So x plus y equal to 0. Now you assume that the x is equal to s. So s plus y equal to 0. So y equal to negative s. So therefore, your eigenvector for the lambda equal to minus 4 equal to 1 and minus 1s. After you have done for lambda equal to negative 4, then you do lambda equal to minus 2. So negative 3 plus 2, 1, 1, negative 3 plus 2. Then x, y equal to 0 and 0. Negative x, so negative 3 plus 2 is negative 1. So negative 1 multiply with the x, so it's a negative x. Then plus with y times with 1, so you get plus y. So 0, so similar to this one, you have the x plus y. Sorry, x minus y equal to 0. Then you assume the x equal to s, therefore negative s plus y equal to 0, then y equal to s. So your eigenvector for lambda equal to minus 2 equal to 1, 1 and s. And the third step is to find whether it's linearly independent or not. So you write down the eigenvector for lambda equal to minus 4, you get 1 and negative 1. Okay, this one. Okay, 1 and negative 1. So you write down here 1 and negative 1. And then the eigenvector for lambda equal to negative 2, you have the 1 and 1. 1, 1 here. Right? Then you multiply and then minus with this. So 1 times 1 minus with 1 and multiply with minus 1. So you get 2, which is not equal to 0. So we name it as linearly independent. And then the step number 4 is to find the general solution for the homogeneous system. So YC x is equal to C1. Okay, for lambda equal to -4, you have 1, -1, exponent -4x. So this is for lambda equal to -4. Plus C2, 1, 1 for lambda equal to -2. So -2x. So this is the part for the homogeneous system. Now we want to find the particular integral, so which is referred to the part 2 for the non-homogeneous. So this is to find the yp. So first of all, in order to find the yp, we need to assume the yp first. So what is the g value? If you refer back to the question, okay, this is your g, -6 exponent -2x and 2 exponent -2x. So we refer to the table. Since just now is a case of exponent, so we can use the u1, u2 exponent -2x. And then we check whether this yp same as the yc or not. So this yp is the exponent, u1, u2 exponent, and yc also exponent. So is it the same? Yes. Exponent -2x, here also have exponent -2x. So it is the same. Yp same as yc. So cannot. So we need to assume a new yp, which is multiply with x. So you have u1 multiply with x, and then u2x with v2. This one you can get it from here, okay, also from the table. And then we check again, this yp same as yc or not. So yp is this one and yc is this one, so it is not the same. So yp is not the same with yc. Okay, next step is to find the yp prime. Okay, yp prime from the yp. Okay, in order to obtain the yp prime, we see here you have the u1x plus v1, u1x plus v1, and as exponent -2x. So we can have a two group u and v. So we can assume the u is equal to exponent -2x and u prime equal to -2 exponent -2x. So v equal to u1x plus v1 and u2x plus v2. So when you differentiate the v, you get v prime, we get u1 and u2. So now yp prime equal to uv prime plus vu prime. That's equal to exponent -2x, then v prime is u1, u2 plus v is u1x plus v1, u2x plus v2, then u prime is -2 exponent -2x. And then the third step is to compare the yp prime with y prime. Okay, as you know, yp prime equal to ay plus g. So yp prime you obtain from here, yp prime, so we copy down u1, u2 exponent -2x minus with 2 u1x plus v1 u2x plus v2 exponent negative 2x, okay, equal to ay plus g. Ay plus g is referred back to the question. Okay, so this is ay plus g. Okay, this is the ay plus g. Y is referred to the letters yp. So this is the a, and then y, plus with g. G is negative 6 exponent negative 2x and 2 exponent negative 2x. So you can simplify. Okay, how do you simplify? Is my way to simplify is I collect all the exponent negative 2x and also x exponent negative 2x. So you have the negative 2u1. Now I want to collect the x exponent negative 2x. So here I have the x here. So I will have negative 2u1 and negative 2u2. So this is for the x exponent negative 2x. And then plus with exponent 2x. So I have the u1 and also the v1. So u1 minus 2v1 and u2 minus 2v2 exponent negative 2x equal to negative 3u1 plus u2 and then u1 minus 3u2. So this is for x exponent negative 2x. For the x exponent negative 2x. I have skipped some steps. Maybe I just rewrite again. I show it step by step for you. So first of all, you need to multiply in this one. Okay. So you have negative 3u1x minus 3v1 plus u2x plus v2. Okay. So you need to solve the matrix here, the multiplication of the matrix here, the product of the matrix. And then second one is the u1x plus v1 minus 3u2x minus 3v2. So this one I will multiply with exponent negative 2x. Okay, then plus with negative 6 exponent negative 2x and then 2 exponent negative 2x. So once you have I expand the product of this matrix, so I will get, you simplify it. So similarly to the left hand side, I separate into the x exponent negative 2x and the exponent negative 2x. Here at the right hand side also can. If you look at here, this is for the x exponent negative 2x and this one and this one belong to the exponent negative 2x. So this one also the same is referred to the exponent 2x. So I can sort out and then categorize into two for the x exponent negative 2x and exponent negative 2x. So I sort it out for the x exponent negative 2x first. So I have a negative 3u1 plus u2. And then I have the u1 minus 3u2. So this is for the x exponent negative 2x. And then plus with second category, that is the exponent negative 2x. I have the negative 3, this one, negative 3 v1 plus v2 minus with the 6, this one. And then v1 minus 3 v2 plus 2. So this one is for the exponent negative 2x. Okay, then next is by equating the coefficient. Okay, I compare for the coefficient of x, x1, negative 2x. What do I get? So for the left hand side, I have the negative 2u1 and u2. So negative 2u1, negative 2u2. And then for the right hand side, I have negative 3u1 plus u2 and u1 minus 3u2. Okay. So I bring the negative 2u1 to the right hand side. Okay, so I will collect all the u1. So negative 3u1, okay, plus this one I bring to the right hand side. So I have the 2u1 plus u2 equal to 0. And for the second line, I have the u1 minus 3u2 plus 2u2 equal to 0. So this one I solve it, I will get negative u1 plus u2 equal to 0. And then this second row, I will get u1 minus u2 equal to 0. So u1 equal to u2. Then I assume that u1 is equal to s. So minus s plus u2 equal to 0. So u2 equal to s. So therefore u1, u2 equal to 1 and 1s. Now you compare for the exponent negative 2x. So u1 minus 2v1, u2 minus 2v2 equal to negative 3v1 plus v2 minus 6, v1 minus 3v2 plus 2. Again, you assume that the u1 equal to s and u2 equal to s again. So s minus 2v1, s minus 2v2. So equal to negative 3v1 plus v2 minus 6, v1 minus 3v2 plus 2. So negative 3v1 plus 2v1, so you bring to the right hand side, 2v1 plus v2 equal to 6. So this one you bring to the left hand side, s plus 6. And then the second row is, next row is v1 minus 3v2 plus 2v2 equal to s minus 2. So when you solve, you simplify, you get negative v1 plus v2 equal to s plus 6. And then for the second row is v1 minus v2 equal to s minus 2. So this is equation 1. And then, so you want to get a v1. So v1 equal to s minus 2 plus v2. I assume this is equation 2. So I insert the equation 2 into the equation 1. So I will have negative s minus 2 plus v2 equal to s plus 6. So negative s plus 2 minus v2 plus v2 equal to s plus 6. I solve this one. This one cancel. Negative s plus 2 equal to s. I bring the s to the left hand side. So minus s equal to 6. So minus 2s equal to 6 minus 2, you get 4. And then 6, s is equal to negative 2. So this is equation number 3. Then I insert the equation number 3 into the equation number 2. Equation number 2 is the v1, s minus 2 plus v2. So v1 equal to negative 2 is the s, minus 2 plus v2. So v1 minus v2, you get negative 4. Now you assume the V1 equal to S, then S minus V2 equal to negative 4. V2 is S minus S plus 4. So V1 and V2, the vector V1 and V2 equal to S plus 4. Alright, so my YP equal to U1x plus V1 and U2x plus V2 exponent negative 2x. So I substitute the U1, V1 and U1, U2 is 1, 1, S plus the V1, V2, I will get S and S plus 4. Okay. And you obtain the S. So just now you obtain the S is negative 2. So I can substitute the value of negative 2 in the YP. So since S is equal to negative 2, so my YP equal to negative 2x minus 2 and negative 2x plus negative 2 plus 4. So I will get negative 2x minus 2 and negative 2x plus 2 exponent negative 2x. So this is the part 2. The part 3 will be the general solution. Okay, part 3 is the general solution. Y equal to YC plus YP. So YC, you still remember that one is a C1, 1, negative 1, exponent negative 4x. Okay, plus C2, 1, 1, exponent negative 2x. And then plus with the YP. YP, this is your YP. So negative 2x minus 2, negative 2x plus 2. Exponent negative 2x. And then part number 4. That is the particular solution by considering the initial condition. Do you still remember what is the initial condition? The initial condition is y0 equal to 1, negative 1. So this means that when x equal to 0, y1 equal to 1, y2 equal to negative 1. Alright, so I substitute in. So 1, negative 1 equal to C1, 1, negative 1, exponent 0, because the x is 0, plus C2, 1, negative 1, 1, 1, exponent 0, plus, okay, here, 0, substitute into the x, so 0 minus 2, 0 plus 2, exponent 0. So now I have 1. I have the 1 here for this one. And then I have the 2 here. So I have a plus 2 equal to C1 plus C2. And then second row is minus 1 minus 2 equal to negative C1 plus C2. So this is equation 1, equation 2. So C1 from here, I know that C1 equal to 3 minus C2. So now equation 3, substitute into the equation number 2, I get negative 3 equal to negative 3 minus C2 plus C2. So negative 3 equal to negative 3 plus 2C2. So C2 you get 0. Yes, 0. And this is equation number 4. And I get C1 equal to 3 minus C2. So 3 minus C2. C2 is 0, so I get 3. So at the end, the Y equal to C1. So, okay, C1 already have the answer. So I straight away write down the answer. So C1 is 3. Okay, then I will have the 1, 1, exponent negative 4x. So this one actually is you copy down from here. So from the initial condition, you'll find out the answer for C1 and C2 and just substitute in. Okay? And then plus with C2. C2 is 0. So nothing. So nothing for the C2. So you left it 0. And the last part is the negative 2x minus 2 and negative 2x plus 2 exponent negative 2x. Okay, that's all for this question. I hope you can understand.